Everything in the physical world around us, from the air we breathe, the chairs we sit on, to the food we eat, are different forms of matter made up of atoms and molecules. Chemists are people who study chemistry, or the science of matter. As early as 1000 BC, ancient civilizations used fire to develop technologies to create iron, glass, and pottery. Today, chemists specialize in many different disciplines of chemistry, with applications in many different fields such as pharmaceutical, industrial, organic compounds, and materials.
My name is Mike Savina, and I'm a chemist at Argonne National Laboratory. I work for the Materials Science Division. We work on all kinds of things like superconductivity, materials for making new supercomputers. My part of it is analytical chemistry. The main part of my job is to analyze stardust grains. These are tiny, tiny little dust grains that you can't even see that were spit out by stars many, many years ago, long before the sun was even born. And we actually have little samples of them here in the laboratory that our colleagues collect for us. They're so small you can't see them, but we've built instruments with lasers and microscopes and a lot of high-end computers and equipment that we can actually analyze them one by one. And what we're looking for is little fingerprints in there, little trace elements that tell us what kind of star made that grain, because if we can find that out, we can find out what's happening in the belly of a star that died long before the sun was ever born. It turns out that stars are giant nuclear reactors in the sky. They're spewing out atoms all the time. That's where all the atoms that are in our body and in the Earth came from, is originally from stars. So when we're studying that, we're trying to figure out, how did the carbon in my body come to be? Well, it came from a star somewhere. And by looking at one of these tiny grains, I can tell you how that was made inside that star, inside of a star that's no longer here. Stars make atoms, and those atoms float around in space, and they eventually end up in big clouds somewhere, and that big cloud of gas and dust will compress down and become a new star. We're always recycling in the universe, and that's what happened. That's how the sun and the solar system formed. But unfortunately, all the stardust in the solar system when the sun was born got melted because the sun was so hot. Almost all those grains are gone. But there are some tiny little asteroids floating around the solar system that never melted, and they still have their original stardust in them. And occasionally, those will collide, rocks will chip off, one of those rocks will come to Earth, and that's what we see as a meteor streaking through the sky, and it hits the ground. Someone picks it up, and if it's the right kind of meteorite, geologists can dissolve that up in acid, and out comes these tiny little stardust grains, and that's what we have here in the lab to analyze. We do solar wind research on this one, so we have actual samples of the solar wind, which is atoms that are spewed out by our sun. I always knew I wanted to be a scientist, even though when I was a kid I didn't really know what a scientist was or what scientists did, but I was always very interested in nature and in the physical world. I would ask questions like, why do trees stop growing? Why don't they just get to be a mile tall? Why do they only get to be 100 feet tall? So I was always interested in questions like that. Somehow vaguely I knew that's what scientists did for a living, but it didn't really matter to me that was science. It just mattered to me that it was interesting and I liked it, and I just kept doing it. I chose chemistry because out of the sciences that was the one that came easiest to me, and also it was the most practical one where I knew I could get a job. I actually went to a vocational school originally and learned to be a chemical technician working in the lab 30, 40 hours a week, even while I was in school. Later on, I started working for a big chemical company and took some night classes, and then I left there and went to graduate school. One of the practical applications of studying stardust is that you're studying nuclear reactions. And the nuclear reactions that happen in stars are the same ones that happen in nuclear reactors on Earth, and also in nuclear explosions for nuclear bombs. And so a part of my research now is called nuclear forensics, where we try to look at material not from explosions but simulated materials like that, and do the same analysis on them that we do on stardust. But instead of trying to say what kind of star did this come from, we're trying to say what kind of nuclear reactor did this come from. We're trying to track down nuclear materials around the world to see where they came from, to keep that stuff from spreading so that it doesn't end up in a bomb somewhere.